presenting on the impact of powder source of processing uniformity of superconducting wire using digital image analysis.
Yeah, that's kind of a mouthful. Hi everyone, my name is TJ Louie and I'm a material science and engineering major here at UW-Eau Claire. Our research involves investigating the superconducting materials involved in fusion technology. Let me explain. It seems that all too often we are hearing about how we should look at our energy consumption and look for greener, more sustainable ways of producing energy. To do this, many areas are being investigated to produce high efficiency, low pollution ways of creating energy. To tackle this problem, scientists are exploring the exciting field of fusion technology. Our superconducting wires, which can carry electricity with zero resistance, are excellent for creating the large magnetic fields used to contain the fuel source in these devices. These large magnetic fields are then used to trap and levitate tiny hydrogen atoms, which are then smashed together to create this completely green type of sustainable energy. The biggest problem with fusion technology is the cost associated with building and perfecting these massive devices. An example of one of these devices is the ITER fusion reactor based in France. This is a multinational $20 billion project that weighs about 3 times the Eiffel Tower, so the scope of these devices is huge. What we are trying to do is reduce the cost of the wire and the overall uniformity, and the overall size of the machine by investigating the uniformity of the internal substructure of the wire. To help explain what this means, we can look at our wire like it's an oil pipe. If an oil pipe has cracks, leaks, or non-uniform areas, you're going to reduce the flow of oil and therefore lose lots of money. We can look at our wire in the same way, but instead of talking about the flow of oil, we're talking about the flow of electricity. So, to characterize and identify these non-uniform areas, we've developed a procedure using digital image analysis. So what we do is we take a section of our wire, polish it up, and then take high-resolution images of the wire using scanning electron microscopy. We can then collect important information on the wire using our digital image analysis program. We then share this information with the manufacturers of the wire. So from that, we found that the source of the powder and the wire impacts the overall uniformity. We can also see a change in uniformity from one end of the wire to the other. With this specific information, the manufacturers can in hopes produce a better performing, more cost-effective wire. So, with better performing superconductors, we can build high-efficiency, more compact magnets used in these large fusion devices. This can make nuclear fusion a more economically attractive option for the production of energy. This, in turn, can lead us to a greener, more sustainable future. Thank you.
Are there pieces of your process that you feel like are more efficient, or is it a cost component, or is this really the only thing that is available to evaluate the efficiency of the superconducting wire?
So basically, our procedure is really good at identifying things that the manufacturer can then change about their process. So it's pretty wide range, and it can be used on other superconductors as well.